In this video, I will show you how to convert square wave to sine wave, then choosing an inductor according to the inverter's capability. Step by step in details. This is a DC 12 volt to AC 220 volt inverter. It has been set up for showing its waveform of the output voltage with a mini oscilloscope. Switch the power on, we can see the output waveform is the modified sine wave. As long as the waveform looks like this, it can be converted to sine wave, with a couple of parts involved. This video is the supplementary video on my channel, which showed how to convert to sine wave from the inverter. That is the similar to this one. The L and C filter circuit secured on the board, used in that video. An inductor and a 2 μF capacitor are there. The inductor's current capacity is 0.43 ampere marked on the inductor. This inverter is able to work continuingly with 300 watt capacity. So it can be written 300 watt equals I for the load's current times 240 volt, which will be the output of load's voltage. Then, I equals 300 divided by 240 equals 1.25 amperes. The inductor's current capacity is 0.43 amperes, which marked here. So how many inductors will the inverter need? 1.25 divided by 0.43 equals 2.9, taking it as 3, total of 3 same inductors together to match the inverter's capacity. A 2 μF capacitor, 3 inductors from recycled fluorescent light, and that inverter together will make a sine wave inverter. Here we go. 3 inductors, 2 capacitors, an output socket, and a pair of wires for connecting the inverter have been secured on the board. They are connected, according to this diagram. Three inductors connected in parallel secured along here. Chosen 2 capacitors in parallel combined. And 1 μF capacitor is there, and underneath it is a capacitor with 2 μF, total of 3 μF, and 400 volt rated. The wires connected are looped here. The output of AC 240 volt socket is secured there. A wire marked number 1 is the one with red in color. A wire marked number 2 is the one which connected to left-hand pin in the output socket. A wire marked number 3 is the one which connected to right-hand pin in the output socket. Whole thing then covers by a DIY made cover. And stick a label on it. The inverter need to be open to have something done. The white plug I'm pulling out from the main board is the inverter's output socket of AC 220 volt. I need to have a pair of wires, which are connected to the red and black wires from the plug. All done. A pair of wires are here. This has been connected to red wire. That connected to black wire from the white plug. Back to the black box, which consists of 3 inductors and 2 capacitors made previously. The sticker on the top of box indicates its continuing workability at the output socket here. Now putting the original inverter on the top of the black box, then connecting wires regardless wires of the color match. It will not be any mistake or misconnected because they've been set up correctly. 2 of these black sockets will not be the output of the outlet anymore, covered them. This mini meter indicates the battery voltage. However, the meter on the right hand is not going to indicate the final output of AC voltage figure. Covered it as well. The meter covered is the voltage measured between number 1 and number 3 from the diagram. However, the final voltage measured from the socket here is between number 2 and number 3, which will be the output of sine wave from the socket. Things have been set up for testing run. The black cable plugged into the multi-socket set from the inverter's output, the white cable connected to an oscilloscope, and the multimeter's ampere position selected for no load measuring from battery. Connected battery. Then turned the switch on, the multimeter indicated 0.7 ampere for no load current from battery to the inverter, and sine wave indicated on the oscilloscope. A 70-watt bulb has been plugged into the multi-socket set, the multimeter's AC position selected for measuring the output voltage with a load. Connecting battery. Then turn the switch on. The bulb is glowing stable. Sine wave is showing on the oscilloscope. AC 242 volt indicated by the multimeter. All good. Thank you for watching. Please like, share, comment, and subscribe if you have enjoyed the video. Your encouragement is my motivation.